Can anyone confirm me that my screen is visible and my voice is clear? Can anyone confirm me? Hello? Is my screen visible and my voice is clear? Can anyone confirm me?
Ah, yes, sir, it's visible.
Yeah, yeah. Right. So let's start with today's discussion. So let me check whether I've started the recording. Yeah, yeah. So we will start the discussion of this PLDs. That is nothing but programming, programmable logic devices. So before FPGAs, these were in use. The devices called programmable logic devices, which are nothing but the programmable logic devices are the electronic components. Basically, these are the ICs, integrated circuits, which can be reconfigurable. Okay, same like FPGAs, these also can be reconfigurable. Okay, and these offer flexibility in the design, allowing the user to configure and reconfigure the hardware to perform specific functionalities. So these are more flexible and they can also be reconfigurable. Okay, so PLDs are divided into two types. One is SPLDs and another is CPLDs. So SPLD stands for simple programmable logic devices and CPLDs stand for complex programmable logic devices. Okay, so in SPLDs are further divided into PROMs, that is programmable read-only memories, and PLAs, programmable logic arrays, and PALs, programmable and logics, and GALs, etc. So like this, we have SPLDs, different categories of SPLDs, and we are also having CPLDs. So after this SPLDs and CPLDs, FPGAs were introduced. Okay, so we can say these are pioneers of FPGA. Okay, yeah. So let's start with the PROM, that is programmable read only memory. Read only memory. So as the name suggests, it is a read only memory, which means it is a volatile memory. Sorry, which is a non volatile memory. So what is the difference between the volatile and non volatile? So, volatile devices are the devices which lose the content or which lose the data which has been stored in them when the power is removed. So, let's say a volatile device is connected to a power circuit, power supply. So, if the power supply is removed from this device, then the data which is stored inside this device will be lost. Whereas in case of non-volatile devices, the data which has been stored into this non-volatile devices will be remain even after removal of this power supply also. For example, our ROM is a non-volatile memory. Okay, is this clear? The difference between the volatile and non-volatile? Yeah. So this, as the name suggests, this yeah. Say suppose if we have a device, it is a non-volatile device. Let's say it is a volatile device, and this device we are storing some data into this device. We are storing some data into this device. Okay, so the power supply we will connect to this device. Okay, we will connect this power supply and we will store some data into this device. This is a volatile device. So after removing this power supply, what happens? The data which has been stored into this volatile device will be erased. Okay, the data which has been stored into this volatile device will be erased. So after connecting power supply again, we should again program this volatile device in order to store the data into this device. So as long as power supply is supplied to this device, the device can withhold the data. The device can hold the data. As soon as we have removed the power supply, the data will lose its sorry the device will lose its data. Whereas in case of non-volatile devices, Whereas in case of non-volatile devices, what happens when we program the device or when we store some data into this device, when there is a power supply, the data will be stored into this non-volatile device. And when we remove this power supply, the device will hold the data. It will not lose the data. It will hold the data. So again after giving the power supply also it will hold, and after removing the power supply also it will hold the data will not be lost. Okay, is this clear? Is this clear? Yeah. For example, the use case of non-volatile devices can be our TV remote. Okay, so in case of our TV remote, the chip inside this TV remote, um all the functionalities of that remote will be stored into the chip. Okay, so if we remove the power supply, like if we remove the battery also, the functionalities of that chip will be stored. So we are using ROM in that case. Okay, we will be using ROM, which is a non-volatile device. All the functionalities which has been coded into the chip will be contained, it will not be lost. Okay, so because we are using ROM, all the functionalities, all the behavior of the chip will be coded and it will be stored inside a ROM. So that power supply is removed also, the data will not be lost from this chip. Is this clear? Yeah, I hope it is clear. So this is the difference between the volatile device and non-volatile device. Now, so the PROM is a non-volatile device. It is a non-volatile device, and it is read-only memory. I hope you know the difference between the read-only memory and RAM, random access memory, or else I will explain it also. Is it clear? Are you familiar with that? Can anyone confirm me? Are you familiar with the difference between the RAM and ROM? Read random access memory and read only memory? Yeah. Okay. So it is a read only memory, programmable read only memory. Programmable in the sense we can reconfigure the device. I will show why we are using this term programmable now. Read only memory. Now, in this PROM, you can see these dots, right? So this dots indicate it is a predefined link that you cannot alter this link. You cannot change this link. Okay, these links are, say, these are fixed. Okay, and you can observe the cross marks. These are programmable links. Okay, see the difference. These cross marks are programmable links, and these dots are predefined links. Okay, yeah. So you can see these dots are connected here. So what is the function you are getting? A bar is connected. From the NOT gate, you have a connection to the AND gate. A bar, B bar, and C bar. Okay, you have A bar, B bar, and C bar. Here also you have A bar, B bar, and C. A bar, B, C, and A. Sorry, A bar, B, C. Is this clear how I am forming the equations? Is it clear? So for each address, you will be having set of equations. So these are predefined links. You cannot change these links. Is this clear? The equations are clear. How am I getting the equations? If not, I will explain it again. Yeah. Now here you have, so these are nothing but min terms. Here you have 0, 0, 0 to 1, 1, 1 min terms. That is from A bar, B bar, C bar to you are having minterms A, B, C. Okay. So these minterms are available to you. for each address. Now, like this, you are having each minterm, each possible minterm. Okay. Now at the output, these links are programmable. So how can these links be programmable? So there are two technologies to make these links programmable. One is fusible link technology, and another is anti-fuse technology. Do you remember this? If you have attended the previous sessions, we have discussed this, right? Fusible link technologies and anti-fuse technologies. Anyone who attended the previous session remember this? Fusible link technologies and anti-fuse technologies. Anyone from previous session? Yeah. So can you tell me, uh, after programming using this fusible link technology, is it possible to reprogram it again? After making a connection using this fusible link technology or anti-fuse technology, is it possible to reprogram it again, or is it possible to make alter that connection? Yeah. So the main disadvantage of this PROM is, once we have made a connection in this programmable link, for example, here using the here using the fusible link technology, we have made a connection here, and rest all we have left as it is, and here we had made a connection using the fusible link technology, and here also we have made a connection like this using the fusible link technology. So is it possible to change this connection, or is it possible to remove this connection using the fusible, if we have made this connection using a fusible link technology or anti-fuse technology? If we have made a connection, is it possible to remove this connection? No, right? Yeah. So this is the main disadvantage. So after the connection is made, if the user had made a connection using the fusible link technology or anti-fuse technology, he cannot alter this connection. Okay. Keeping the disadvantage aside, um, if we use we can use this fusible link technology and anti-fuse technology. So after making this connection, what is the output W, and what is the output X, and what is the output Y we are getting, which is nothing but W is equal to what we are getting, A bar, B bar, C bar, and what is the output X we are getting, which is nothing but A bar, B bar, C, and what is the Y we are getting? Here you can see A bar, B bar, and C. Okay. You can make the connections. So the user can make the connections. He can make custom connections. So according to his requirement, he can make as many as connections he want. So according to the output he want, for example, if he want A bar, B bar, C bar plus A bar, B, C bar, so he can join this connection. So what may be his output? W is equal to A bar, B bar, C bar plus A bar, B, C bar. So what is the output? He will get he will get A bar and C bar, right? Is this clear? What I am trying to explain, is it clear? If you are not able to understand, ask me. I will explain it again. Okay. Yeah. So this is how the user can program the device only for once. Okay. So this is how the user can program the device only for once and make his custom logic. Okay. So this is about PROM. Now after this we have PLA. Okay. Programmable logic array. So in this programmable logic array, we have same. Wait a minute. Yeah. So we were discussing about programmable logic arrays. So in case of programmable logic arrays, uh, the difference is that we don't have any predefined links. We have all the programmable links only. So in case of Prom, we have predefined links as well as programmable links, whereas in case of PLAs we have only programmable links. So the links which are for AND gates are programmable, and the links for OR gate are also programmable. You can program the links which are associated with the OR gates, as well as you can also program the links which are associated with AND gates also. So like this circuit is offering more flexibility. Okay, this is offering more flexibility. For example, you can program this link a bar, and if you program this link a bar, and can also program this link b bar, c bar, then it will get a bar, b bar, c bar. It will be given here. So here if you program this, it will be given to the output, that is w is equal to a bar, b bar, c bar. And you can program this AND gate also, a, b, c. So using any link technology you can program it. And this abc you want to give it from y, then you can program this y is equal to abc. So basically you are programming each and every gate and each and every node. So this is about programmable logic array. Okay, now coming to the one more structure called CPLD, which is complex programmable logic devices. So after this yeah. So after this PROMs and PLAs, we are having this CPLDs. So this, with the help of PROMs and PLAs, you can achieve a only a small set of Boolean expressions. You can only have you cannot build complex circuits using this PLAs and PROMs. Okay, so next in the order, we will be having CPLDs. So in the PLDs only we have discussed it, right? SPLDs and CPLDs. SPLDs we have this, and in case of CPLDs we can build complex equations. We can solve the complex Boolean algebraic equations, or we can perform complex functions with the help of CPLDs. Now is it visible? Hello? For others, is it not visible for others also? Yeah. So in this case of complex programmable logic devices, let's see the structure of the CPLDs. So in this CPLDs, we will be having a interconnect matrix like this. So this matrix will connect all these blocks, all this, these are also called as islands. So all these blocks are connected together with the help of this programmable interconnect matrix. So this will basically connect all the blocks. Not visible. Hello. For others also it's not visible.
Your yeah, it is visible actually. I think problem is with her.
Okay, okay. Yeah. So this standalone blocks are nothing but we can build this. So this standalone blocks are built with PLDs. Okay, so this can be SPLDs. So these are standalone blocks, SPLDs. Okay, which we have discussed in our previous slides, right? So this all SPLDs will be connected together with the help of this programmable interconnect matrix. Okay. So like this, all these SPLDs will be connected by our programmable interconnect matrix. So individual SPLDs will perform some individual tasks, and all these SPLDs are connected with the help of this programmable interconnect matrix, and it will perform a complex function. So a complex function may be divided into a smaller parts, and the each SPLD will perform individual tasks, and combinedly all the SPLDs will be connected by with the help of this programmable interconnect matrix. So all the complex functions will be executed completely. Okay, and these are input and output pins for interfacing with the external interfaces. Okay, so we can also have input and output interfaces with this CPLDs. Okay, now, so this was the structure of CPLD. Let's see a table which is differentiating PLDs and CPLD. So in case of programmable logic device like wait a minute, I think it's a small mistake. Yeah. Okay. Yeah. So in case of PROM, the programmable elements are AND arrays. So you can see in case of PROM, sorry, it is it is PAL, and this is PROM. Okay. So in case of PAL, the programmable elements are the AND gates, and in case of PROM, the programmable elements are OR gates, and in the case of PLAs, both AND and OR gates can be programmed. Okay, and in case of CPLDs, we have multiple logic blocks, which we have seen in the previous slide. Okay, and flexibility of PAL is low and PROM is medium and PLA is high, since both the AND gates and OR gates are programmable, so it has high flexibility, and CPLDs are also having high flexibility. Cost is low for PAL, it is PROM also low, and PLA is medium and CPLD is also medium. Availability, it is high for PL, high for PROM, and low for PLA, and medium for CPL. Speed is high in case of PAL because only AND gates are programmable. Okay, and speed of PROM is also high because only OR gates are programmable. And coming to PLA and CPLD, speed is moderate. Okay, and logic functions implemented, sum of products, programmable logic functions, and SOP, and CPLDs can perform all the combinational logic functions. But the main disadvantage of this CPLD is the speed. The speed is the main problem. It is moderate, and CPLDs will also contain less resources. Like it will not have many resources in it. Okay, so this was the difference between the CPLD and the SPLDs. Okay. So yeah, so that's all for today's session. So in our next session, we will start with the introduction of FPGA, like what are all the blocks we are having in the FPGA, and before that, we will cover one more topic, like how to program this CPLD, how to program CPLD. Is a very small topic. We'll discuss it, and the same procedure we will follow for FPGA also. Nearly the same procedure we will follow the programming for FPGA. Okay. So that's all for today's session. So if you are having any doubt, you can stay and ask, or else we can end the session. Thank you.